Polar bears and polar cubs, it's time for a couple more solution math problems. So the first one that we're going to talk about is dilution. There are two equations for dilution. You have M1 V1 equals M2 V2, where M is molarity and V is volume. You also have a second equation where if you take M1 plus or M1 V1 plus M2 V2, that's going to give us M3 V3. So what the second equation is telling us is if I take two different solutions of the same compound and I mix them together, this is how I can calculate the resulting molarity of that. You might go, well, if I'm solving for this, I really have two on this side that I need to solve for. Not really, because you know V1 and you know V2, and when you add up volumes, that would give you V3. So let's go ahead and do a practice problem together. We have V1 0.200. Remember, it's got to be in liters. And then we have M1 is equal to 6.0 molar. And we're trying to go to an M2 of 3.0 molar. So what's going to be our new volume? Well, if we put 6.0 times 0.200, remember, all you have to do is just divide it. So the new one is 3.0. We're going to be able to find V2. Divide it up, and you should get 0.400 liters. Or, if you wanted to put it back into milliliters, it would be 400 milliliters. Now, the hardest part is technically speaking, this shouldn't be there because it only has two sig figs. So you would have to write it as 4.0 times 10 to the second. And the identifier on that would be HCl. The next one today is parts per million. Now, with parts per million, it is a lowercase p, a lowercase p, and a lowercase m. This is very similar to percentage concentration in the fact that it's grams of solute divided by grams of solution. The only difference is now instead of multiplying by 100, you're multiplying by a million, 10 to the 6. So this is used for very low concentrations of things. We really use this in like drinking water and things like that, where you have a very minute amount of something in the large vast of the water. So we have grams of solute .00123. You have grams of solution, 1683. So we're calculating for parts per million. So we're just going to use that equation right at the top. So parts per million is going to be equal to 0.00123 divided by 1683 times 10 to the 6th. So when you plug that into your calculator, you're going to have 0.00123 divided by 1683. And then we're going to move the decimal to the right 6 times. 1, 2, 3, 4. That gives me 0.73. Now, this should be written in scientific notation. So that gives us 7.3 times 10 to the negative first parts per million of NaBr. And that is parts per million. All right, best of luck on your worksheet. Let me know if you have any questions.